1. What are earthworks? Earthworks are engineering works that involve the processing and movement of massive quantities of soil and rock. These works are typically conducted during the civil engineering and construction processes and involve operations such as digging, moving, and grading soil and rock to create a desired shape or elevation. Examples of earthworks include the construction of dams, canals, and terraces, as well as the excavation of foundations for buildings and roads. Earthworks are also used in landscaping and environmental restoration projects, where the goal is to reshape the land to create a desired appearance or to restore natural features. Earthworks can have a significant impact on the environment, and it is important to carefully plan and execute these operations to minimize negative impacts. This can involve measures such as erosion control, sediment control, and the use of appropriate equipment and techniques to minimize soil compaction and other forms of land degradation. 2. Fill materials and compaction. Fill materials are materials used to fill in an area of land to create a level or desired elevation. Compaction is the process of pressing or packing these materials together to increase their density and stability. This process is typically done using heavy machinery such as rollers or vibrating plates. The type of fill material used depends on the intended use of the area being filled. For example, sand, gravel, and crushed stone may be used for road construction, while soil and clay may be used for land reclamation or landscaping. Proper compaction of fill materials is important to ensure the stability and longevity of the finished project. Insufficient compaction can lead to settlement, erosion, and other issues that can compromise the integrity of the structure or surface being built. Therefore, it is important to follow proper compaction techniques and to test the density of the fill materials to ensure they meet the required specifications. 3. Relative compaction and maximum wet density of untreated soils and aggregates. Relative compaction is a measure of how densely packed soil or aggregate materials are compared to their maximum possible density. It is typically expressed as a percentage and is calculated by dividing the dry unit weight of the compacted material by its maximum wet density, also known as its maximum dry density, and then multiplying by 100. Maximum wet density is the maximum density that a soil or aggregate material can achieve under a specific compaction effort and is typically determined through laboratory testing. This value is important for determining the appropriate compaction requirements for a given material. The relative compaction of untreated soils and aggregates is an important factor in the stability and performance of construction projects, as it affects the strength, stiffness, and permeability of the material. Proper compaction is necessary to ensure that the material is stable and can support the loads that will be placed on it. In addition to the maximum wet density, other factors that can affect the compaction of soils and aggregates include the type and amount of compaction equipment used, the moisture content of the material, and the amount of compactive effort applied. It is important to carefully control these factors in order to achieve the desired level of compaction and ensure the success of the construction project. 4. Actual water content of the fill materials and the optimal moisture content. The actual water content of fill materials refers to the amount of water present in the material at a given time. The optimal moisture content, on the other hand, is the specific amount of water that should be present in the fill material in order to achieve the desired level of compaction. The actual water content of fill materials can vary depending on factors such as weather conditions, the type of material being used, and the time since the material was last watered. If the water content is too high, the material may be too wet to compact properly, leading to reduced strength and stability. If the water content is too low, the material may be too dry to compact properly, leading to reduced density and increased permeability. The optimal moisture content for a given fill material is typically determined through laboratory testing and is based on the specific characteristics of the material. This value represents the moisture content at which the material can be compacted to its maximum dry density with a reasonable amount of compactive effort. It is important to monitor the actual water content of fill materials and adjust the amount of water added as needed in order to achieve the optimal moisture content. This can help ensure that the material is properly compacted and that the construction project is stable and long-lasting. Thank you for watching.